So the first thing you're going to want to do is go to ST Microelectronics website, which is st.com. So let's go there, www.st.com, and we're going to go to STM32 Developer Zone, and we want to look for STM32CubeIDE. So we want to get this integrated development environment. So we're going to download it. And I need it for Windows. So I'm going to hit accept. And I do have, you're going to want to register with MyST, get a myst.com login. So you're going to want to register with them. And I have my username and my password I'm going to put in. Here is hopefully I have the right one here. And log in. So you're going to want to register with st.com. They're your buddies. They're going to help you out with the software you need for this. And I'm hoping that this will download. So I'm showing you how to download STM32CubeIDE, and I'm hoping that'll download. And I'm going to start from scratch and show you how to configure the STM32 microcontroller for that allow you to develop your own stomp box. So this is at the very beginning. So we're going to go through the software in today's lessons and what you need, how to configure it, and how to set it up. So we're going to let this download, and I believe it downloaded. So we're going to go look in the folder, the download folder, and we'll bring that out here. So basically is what all you really need is this cube IDE. It's also going to be good to get. We'll also get the other thing that we could use that could help us, going back to the STM Microelectronics website, is the other thing that we could really use. We'll go back to the home page, and so STM32CubeMX is also good to get. So we'll get that also, and we'll download that. So this will be good for developing reports. Sometimes STM32CubeIDE doesn't have quite all the features that STM32CubeMX has. So I'm hoping that that'll download also. And right, we want it for Windows, and we'll accept it. And I believe I was already logged in, so it's not asking for my password again. So both this STM32CubeIDE, this will be the main program we'll be using, the main application program for the stomp box, for this digital stomp box. And this is an extra thing called STM32CubeMX, and we'll be using that also to generate some of the reports. So we could get out of our web browser now. And so we'll get out of that. And this is our downloads folder. So we want to get STM32CubeIDE loaded on our machine. So I believe, the first thing to do is unzip this. So we'll unzip that. We'll extract it all. There it is over there. So we'll hit extract here, and hopefully all that will extract. And we also want to extract our CubeMX, so we'll get that also, and we'll hit extract all there and hit extract. So we'll get all the files, so we could install this on our machine. So the next step is to install these two application programs on our computer. So it looks like we got STM32CubeIDE unzipped. So it gives you an installation file. Let's see, it's pretty good size, almost 1 gig. Yeah, I don't know why our cube, the other one, the CubeMX, isn't extracting all the way. But oh no, that's CubeIDE. Okay, so maybe that's not ready yet. Right, okay, we have to give that a little more time. Okay, 100% complete. Okay, so it took a little time to extract that, but you can tell it's extract now because the icon fills in. So we're going to install our main program that we're going to use to design our effects is STM32CubeIDE. So we're going to install that now. So we'll double click on that to install that. So we'll let that install. So this is our STM32CubeIDE wizard. So we're going to hit next here. And we're going to hit I agree. And this is the default destination folder. So we're going to hit next there. And let's see. So yeah, we'll install these. So there it goes. It's starting to install, and I'll get back when it's done this. It has a question. Would you like to install this device software? I know we're going to need our USB driver, so I better hit install here. Now that it says this is completed, we're going to hit next. And we're going to create a desktop shortcut for STM32CubeIDE. So we hit that. And I believe it made here's the shortcut. I'm going to bring it up over here. Just move it over here. Come on. It's not moving. Okay, we'll just move it over here for now. Doesn't want to move to my other monitor, but anyway, we'll get to see it soon. The next thing I want to do is also install CubeMX. So we have CubeMX here, and we'll install that also. We're not going to use CubeMX too much, but it is a nice tool for generating these configuration reports that STM32CubeIDE doesn't give you. So that was the reason why we're using loading CubeMX. So here's our STM CubeMX installation. So we're going to hit next here, and we'll accept everything. Hit next, and I guess we had read the policy. Hit next, and yeah, we'll install that at the default locations. Hit OK. So yeah, we'll have the shortcuts and everything. All users. Hit next. Okay, so that's installing now. We'll get back to you when that's done. Okay, so that's finished now installing. So we're going to hit next, and we're just going to hit done here, and hopefully we'll have the icon for CubeMX. Let's see, we got the one for CubeIDE finally. So we'll close that up. So there it is. There's CubeMX, CubeIDE. And now I'd like to open STM CubeIDE and then plug in my Nucleo board to get things started. So this is the first time I'm opening it here. So I double clicked on it. and CubeIDE is starting up. So CubeIDE is going to ask if I want to make this is my primary workspace, so I'm going to go with that. That's my default. So I'll say use this as a default and do not ask again. So it's going to ask me a couple questions. Let's see about the firewall. So I'm going to allow access. And over here, improve its products. I'm not going to do that right now, so I'm just going to cross this out. So this is how CubeIDE started up. It started up with, it opened up a PDF file about the release of it. So I don't believe we need to have this on, so I'm going to close that out. So this is, this is the first time going to CubeIDE, and this is what it comes up with. So it comes up with the home page. So we'll continue on from there. So one thing I'm going to do, I'm going to plug in a Nucleo board. So I'm going to plug that in now and see if I get any response from that. And I get a little beep when I plug it in. And we'll take a look at Device Manager just to see what comes up there. So when I plug in my Nucleo board, I get this little folder comes up that's internal to the Nucleo board, and that's a good sign. It's considered to be drive D. So one of the things you want to see is that the driver is set up for the Nucleo board. So you go to this PC and you click on Properties, and this will come up. And then you come down here, you go to Device Manager. And we're going to look at Universal Serial Bus devices, and wanted to make sure, okay, so this ST-Link debug is on, so that's a good sign that my Nucleo board is connected and all the drivers are there. So that's great. So one thing that's always good to do is to make a folder on your PC that you could put links to for your projects. So I'm going to call this STM32, and I'm just going to put links in here, and so what I would do first is go to what I like to do is put it in my documents folder. So let's go to that. So we'll open up Explorer here, and we'll go in Documents. Try to keep it in your local documents. So we're going to make a new folder here called STM32. So everything will really go in there, and I'm really going to just make this a shortcut to that. That'll be much better. So let me delete that, and we'll bring this out as a shortcut. So say create shortcut. I like to take the shortcut terminology out of the folder, so this will be a way I could get to things more quickly. So let's see. Let me see. No, that's not okay. Right. So we STM32, which was linked to my documents folder. I like doing it that way, so when I do backups, I just back up my documents folder, so I don't really want to put anything on the desktop. So that's good there. So the first thing I want to do is open this shortcut I have to my documents folder and make a link to where the projects are kept. So the projects, they're kept. We'll find the link to that. So we'll find that, and I believe the projects are kept on the C drive. Go to Users, and I'm Frank, and it's called STM32CubeIDE. So this is where the projects are at in this workspace. Workspace _1.13.1. That's the version of CubeIDE that we have. So we're going to make a shortcut to that, because this is where our main projects are going to be. So I'm trying to get a point where I could get easy access, because CubeIDE kind of puts files all over the place. So I'm trying to make one directory here with shortcuts in it that'll get me to that more quickly. So I'm going to go to that workspace now, and I have one project I've had done previously. It's going to be easier to start from a previously done project and make a copy of it. And I'm also going to try to show you how to do it from scratch also, if you didn't have this. But I'm going to provide this on my website so you could also copy it also. So I have let's see, I have a USB drive here that has that on there. I'm going to copy it on. And if I can find it here, I believe I had it in this Part 2 section. There was support files. Let me unzip that and try to find that directory. So I'm going to find that. First, let's extract that. Sorry to put you through this, but I'm trying to find a previously done system that I could start with. Okay, so I'm going to get these files, and let's see, they're located here, I believe. Yeah, there I have files from a previous project. So I'm going to copy them into my workspace. So hit copy, and they're all copied over into my workspace. Okay, so now I'm going to open CubeIDE. So CubeIDE is opening now. It takes a little time for CubeIDE to start up. So it's coming, I believe. So there's a CubeIDE. So I'm going to let's see, try to get to try to get to my main directory. I believe if I just close this out, it will take me to the Project Explorer. So let's see, I should have a workspace in there. I believe there should be one in there because I just copied it over. So let's see, so anyway, I'm going to create a new STM project from the existing one because that's what I have. So I'm going to click on this. And see what happens here. Okay, so it's initializing the STM32 target selector. So this is an H7, so it's going to download the repository for the H7 processor. So I'm going to browse here, and I do have an IOC file in here in this workspace here. So I'm going to get to the workspace. So I believe it's over here, users, Frank, workspace. I have it in the workspace already. So here it is over here. I'm going to open that. So this project, I'm just going to name it. I'm going to increment it 1. So instead of a 12, I'm going to call it 13. So I'm going to hit next here. And this is what I have here. So hopefully I'll be able to get the latest. So hit finish here. And yeah, I want to open up that perspective. Okay, there's a looks like there's a new version. So we're going to migrate to the newest version, the latest and greatest. So let's do that. So migrate. So now it wants me to log on to get the latest software for the H7 Cube H7. So I'm going to do that. I'm going to hit OK. And OK. See what it says here. Okay. Okay. So we have that here. So now I'm loading the driver files for the STM32Cube firmware for the H7 processor. So I'm primarily going to be working with the H7 processor on the Nucleo board. So it's a little bit hard to get to this step. I had to log in, and but it is downloading now. So this goes in my repository for the tool chain I'm going to need to do this project. So now this is the license you need for Cube firmware H7. So you want to say I have read and agreed to the terms. So hit finish here. Okay, looks like I got it loaded there. So I got the repository loaded. So the next thing I want to do is in my directory here, I want to put a link to that repository. So if you have other processors, it'll have a repository for each one. So my repository is in this other directory. It's called Frank STM32Cube. So I'm going to make a link to that. Yeah, the one bad thing about CubeIDE, it puts files all over the place. So you have to kind of know where they're at. So I made a link to this repository now. So now if I go into this repository, I do have the drivers for the H7. The main one is this is in here now. So this has all the drivers and everything I need in it. Now I would like to show you how to copy an old project to a new project. As you develop the projects, you're going to add things, but you want to save a previous version in case you need to go back, in case there's problems with the future version. So I'm going to show you how to do that. So this is the one that I was able to copy from the last project. So this ends in EX013. So the only files I'm really going to deal with, there's only two files. And the one file is main.c. So I open that up. So this was auto-generated. So I didn't write any of this code yet, but I'm going to add my code to this. This was all auto-generated by STM32CubeIDE. So the second file is, there's just a little bit of code in there for the interrupts. So I'm going to open that one. But anyway, we're going to work on main.c right now. So what I'm going to do is go to the previous version I had, which I did put into this workspace, and that was exe. The previous version was EX012. So I'm going to go to core and source code. So I'm going to open up this folder main.c from the previous, and I like using Notepad as a text editor. So this is Notepad, which is a nice, a pretty good text editor. And I'm also going to open the interrupt file. So I only really deal with these two files. So I have these two open. So I'm going to go in main C. So now I'm going to start copying the code segments from the old version to the new. So the way this works is going back to the integrated development environment. You only put code between these user sections. So there's a user code begin, user code end, begin, end. But anything out of that, the CubeIDE automatically puts in for you. So I'm going to go put the code that I need into main. So I'm going to be in this main right now. So I'll go back to Notepad. So this is my include section here. So I'm going to, so you can see where it begins over here. So I'm going to start here. And this is previous versions that I had done, and it's mostly just comments in here. So this is, you can see it says the includes ends at that point. So I'm going to copy and go back to IDE. So this is going to be in the include section. So I'm going to paste this in here. So take a quick look at it. I like to put a little bit of spacing in there. And this is where I put my comments for each version that I make, just to keep a little bit of history. So this one is going to be, let's see, so I'm going to copy when I did 12's comments. So I'm going to copy that and paste it back in, but now I'm going to call it 13. So I'm going to edit this and call it 13, and I'm going to put today's date in. Is the 20th, August 20th, and it's based off the previous version, which was 12. So I put all different things. If I add anything, I could put it in here, but this is just basically a copy. The purpose is just to show you how to do this. The purpose is this is a copy of the last version for training. Okay. So that was that section. So now I'm going to look for what's the next section. So the next section is this, it's called private define. So it has some variables in there, not a whole lot in there. It has the I2C address and some of the setups for the LCD. So I'm going to copy that. So copy it. And then we'll go back to CubeIDE. So I want to put it in here. A lot of these things will be have nothing in it, these sections. So I'm hoping that'll paste in. So I'm going to hit paste. Okay, so that's in there now. Okay, so now I'm going to go to the next section. And there'll be some errors here because it's not quite set up. So the next section is called the PV section. That's private variables. Okay, so my section here begins here. And we're going to go down. And this is all the parameter initialization. So I have a lot of effects here. I have up in the 40s. Let's see, I have 43. So this is the end here. So you can see where it ends. So I'm going to copy that and look for the PV section here. And I like to put a space in between my code and so it's always good to check. Okay, so the next section is this PFP, which is private function prototypes. Okay, so that has like it's a short section here just for some of the subroutines, to define the subroutines. So I'm going to copy that and paste that. That goes in here. So I'm going to hit paste. So now we're going to go to the next section. And the next section is user code 2. So that's getting into just after the main start. So this is the stuff that runs on initialization. So I'm going to get that, and that's where it ends. So I'm going to copy that, and we'll paste that into So we're looking for user code 2 is right here. So I like putting a space in there, and then I'm going to paste that in, hit paste, and I'd like to add another line in there. So this is my main while loop. Okay, so we'll get into that a little bit later. I'll explain that to you a little bit better. So the main while loop, that this is the thing that runs at the 20,000 hertz update rate. So I'm going down here. I'm going to copy this section here. This has all the algorithms for the effects. So I have a big use case switch in there to be able to switch between the effects. So it's the C programming language. So I'm going down. So I have 40, I believe it was 43 effects in here. So let's go down to the bottom here. And so I'm just cutting from the text editor. I'm using Notepad. You could just as well use the text editor that comes with Windows. Notepad's a little bit more colorful. Let's see. So I'm going down, still copying. I'm going to do a big cut and paste here. Copy, not cut, but copy. So I'm still going down. So there's some utility things here, setting the pots and some of the buffers. And I believe this, yeah, so this is, okay, so I'm looking for the end of the while loop. Okay. So I'm looking for that. So keep on going. So this puts the displays up on the LCD. Let's see. Okay, so here's where it ends. So you can see user code end wild. So I'm going to copy that, and we'll put that. So that goes right. You can see that's begin, but it goes right in here. So I'm going to paste that in. So it's right in there. So this is the code that I wrote, but everything else is auto-generated. So I'm just going to go back. I just wanted to make sure everything looked good there. Let's see. I have an extra while in there. I don't believe that. I believe there's only one while in there. Let me just go back and check that. Yes, the code drives you crazy. So, yeah, let me undo this. I'm going to do this one again. So I'll just do undo. So I'll go back here. And I didn't really want to copy this while. That's already in there. This always gets you. So I just really wanted to copy from after the while. So we'll do this again. Sorry I have to put you through this, but software is always a pain. So we'll get back down there again and copy that and paste that back. So instead of using the shortcut keys, I'm doing this, trying to use the cut and paste. This way you could see it. So here we go. We're at the end while again. So I'm going to copy that and go back to IDE. So I really wanted to paste it in here. So I'll hit paste. So I'll go down and yeah, I just wanted to look back up again, make sure there's only one while there. So there it is. Okay, so that's good. Okay. Okay, so there's one last section in here at the bottom. So I go back to Notepad, and it's where all my subroutines are. So it's in this user code 4 section. So all this code here is auto-generated, but over here, this is the code that you write. So this is user code begin, and I'm going to go down here. There's a few little subroutines. It ends right there. So I'm going to copy that and go back, and it goes right in here. This is user code 4. So we're going to paste that. Okay, so we'll just give this a nice save. So the next piece of code is in this interrupt, the interrupt service routine. So there's not much in here. There's only a real little bit. I believe it's only 2 lines of code. So if I go to Notepad in here, the only thing I have here is user code begin 0, and this is the interrupt flag that sets the 20,000 hertz update rate. So I want to copy that line. And I believe there's only 2 lines I need to put in here. So I'm going to put it in here and hit paste. It's just the 1 line. And the next thing is for this timer 3. So I set the interrupt flag to 1. So you want to do as little code as possible in this in interrupt service routines. So I'm going to copy that and go back to IDE. So I'm looking down here for timer 3. So it's right in here. It goes right in there. And we'll talk about this a little bit later. We'll get more into the software of this. So that goes right in there just to set the interrupt flag. And I'm just gonna move it over here just to make it look nice. So we'll go save that now. So there's a couple other little things I need to do to get this to compile. So I'm going to want to compile it soon. So I go to project, and I want to go to I believe it's properties. Right. Okay. So just have to do a few more things here. So we want to go to the settings, C++ build settings. So we want to go over here, and I'm going to make this a little bit bigger. So in here, in the compiler, let's see, I got it, I believe it's under compiler. Let's see, we have to, okay, MCU settings. We're going to go to MCU settings. So we use this, we use printf and scanf. So I just wanted to check these and hit apply and close. And then in project, again, I want to go back to properties, and this comes out looking a little bit different now. But I want to go to the compiler. I want to have some an include path because I need to add an include path. So the include path I need to add is in the repository. Let's see, so I think I want to hit this add a path. So I'm going to go show you which path I want to add. In fact, I'll do this soon. Let me I'll show you how to do this, an easier way of doing it. So we made this folder here to the repository. So this is the H7 processor. So I believe it's drivers. And we want to go to CMSIS and DSP. So this will allow us, get all of our libraries. I believe it's include. Right, so this is it here. So I believe we want to include this library. Just want to go back here. Second library. Okay. Right. Yes. Yeah, so we want to go. We want to include this over here. We want to include this, which will add this library, and this has like a lot of our functions, our sine, trig functions, and square root, and things like that. So we'll hit copy. So I just wanted to copy that because that's our include path there, and go back here. So it's a little tricky. This does have a steep learning curve. So we want to add this as an include path. So I'm going to paste that in and say OK, and hit apply and close. And yeah, we'll rebuild this. So there were some areas here that had some errors. I see over here this comment here. Let me just add another slash here to make that somehow that didn't get in all the way. This is just a comment. So sometimes you'll see things like there'll be a question mark, and I don't believe there's any more question marks here. So that's good. So we want to get this to compile without any errors, and I just did it the way to get it to compile. Just hit this little hammer sign here. So we hit it, and it did compile. So that's good. That's good. So wanted to show you a little bit of the files in here, and there's a huge number of files in here, but the only ones we need to play around with is this main C and the interrupt. So the interrupt one, yeah, once you set that, you don't have to mess with that. But the main C, that's where we put all the effects. But there's all kinds of other files in here, all the drivers, and there's a whole mess of them, quite a bit of drivers. And so without this this tool train makes it a lot easier to work with. So I only have to worry about writing code for this main C, and everything else is auto-generated. So now we're going to want to plug in and program our device. So right now I'm connecting it to the PC through the USB connection, and it's now connected. You heard the little beep there. So what I want to do is to program it, I hit this little debug thing. So I hit that, and the first time it goes around and asks you if you want to do it, launch it this way. So I hit OK. So I'm hoping that it's gonna no ST link detected. Okay, let's try that again. Okay. Didn't have enough ports on my PC, so you want to get this, you want to make sure this comes up when you plug it in. So that came up. So we'll try this again. We're going to try to load the device, load our Nucleo board. So hit that. And okay, it wants me to check to make sure my ST link is updated. Okay, so I'll hit yes. And okay, so we have to do a little bit of other work here. So just getting started is always a pain. So we want to so there's a ST link upgrade. So we'll open in update mode, and I'll hit that, and I just want to hit upgrade. Okay, so it's actually going to upgrade the firmware in my Nucleo board. So it's doing that now. And let's see. Okay, looks like that is successful. So we'll close this again. We'll turn this off. So now all we're trying to do is load our device. And I hope it's backwards compatible for my other computer. So hit that, and okay. So now I'm getting security alerts. So I'm going to allow access. So this is on the startup. Okay. So I'm going to switch my environment. And so it did say to download verified, and it did download. Okay, that's good. Good sign there. Okay. So so when you first load the processor, it always begins at the first instruction after the main. But I'm going to come out of debug mode here. I'm going to terminate this, and I'm going to just load it one more time to show you how it would normally load if you don't have to do the initial. This is like an initial one I'm going through. So it's yeah, waiting for debugger. So compiled, and yeah, we will switch to the other perspective. I'm going to put remember my decision and hit switch. So that's good. That's good. So that's starting at the very beginning. So what I like to do, I like to set up some live expressions. I like to look at some of the parameters when I run this. So the first thing I like to look at, it's called the frame counter. So this is just a number that increments for every frame. And then I like to look at, I call it A time. It just represents time. So there's thousands of parameters we could look at. So I'm going to run this now. I'm going to launch it. So the way you launch it is to hit this resume. So you could set breakpoints and do all kinds of neat things for debugging, but I'm going to hit resume. So I wanted to get my program running here, and hopefully it'll run. So let's see what's happening here. And my program isn't running. Okay, so we'll stop this and try again. Okay. So we'll reload the program. And I believe I know what the problem is. It's that I don't have USB power hooked in to the device, so it can't talk. So let me go get that. I'll go get the USB power and hook. So I have the USB power hooked in now, and we'll give this another go. So it's going to download the code again. So I couldn't talk to the devices because I didn't have USB power. So we're going to focus in our live expressions here and everything downloaded. So we're going to hit the go again. So we'll hit resume here. And okay, there it goes. So there's our frame counter. So you could see this thing updates 20,000 times a second. So we're up to 13 seconds, 14 seconds, 15, 16. Yeah, this is a little bit different than what I had before on the previous versions of CubeIDE. It updates much faster here. So you could see the frame counter updating and the time updating on this. So I wanted to talk a little bit about the code here and how it works, how it updates at 20,000 times a second. So what it is, this is the main while loop that is running all the time. But I have a thing called the interrupt flag. Okay, so there's a thing called the interrupt flag, and this is the part of the code that runs 20,000 times a second. So if this is equal to 1, it runs this code. If it's not equal to 1, then it skips out and keeps on continuing with the while loop. So there's a timer that has there's an interrupt service routine. So when the timer runs out, it will be interrupted and go to the interrupt service routine. So I'll show you the interrupt service routine. That's in this file here. So all it does is that it's timer 3. So when timer 3 runs out, it sets the interrupt flag to 1. So it jumps right into this code when the timer runs out, sets the interrupt flag to 1, and this is the code here. So when this is 1, it runs this code. Now at the very end of the code, where at the very end, let's get to the end there. We're gonna find the interrupt flag again, and we'll get to that. So at the very end of the main loop, so this is at the very end. So at the very end, it sets that to 0. So the interrupt flag gets set to 0. So this is the very end, this bracket here. So when it comes back in, it'll skip out that part of the code. So it comes in and runs this part, but over here it skips out that. So it does some background work, and then it skips out, and down in here, after that, it runs this part here that services the LCD display. So just wanted to show how that worked. So I'm going to go through little bits and pieces of the code to give you an idea, what it takes to make a digital stomp box. And we'll go through that shortly of my main.c file where I put all my effects and code. So at the very top here, it has include main H, and basically everything here is just comments. All that stuff in green is comments, and you can put in whatever you want in there. And so I have some include. So this is the include section. So there's an include to the standard input output math.h, and then there's arm math.h and string. So these are some of the libraries that I use, the standard C libraries. And so this section of the code is private defines. It's just some defines. One thing I define is the I2C address of the audio codec. And there's some defines for the LCD, the 1602 LCD. And so all this over here is all auto-generated. But then over here, this is the beginning of my PV, my private variables. So at the beginning here, this is the interrupt flag that is also used by that interrupt service routine. So I start setting up my parameters. So some of the types here are unsigned integer, 32-bit unsigned integers. And then I have signed integers that are 32 bits. And these are a floating point. So this is the ADCs and the analog to digital converters and DAC. Now these are 32-bit that are inside the audio codec that interface to this system. And so this is defining the parameters for the A to Ds and D to As. It's stereo, so there's a left and a right channel. And this is my frame counter. And this is just counts every frame. And this is my update rate, which is 20,000 hertz. And this is 1 over the update rate, which is, it's down here. It's right here. It's 0.000005, just 1 over 20,000. And this is the parameter I use to store time, floating point time parameter if needed. And so I have some buffers for, these are 32-bit buffers for the transmit for my I2S interface, and this is the receive for my I2S interface. So it's a small array, just two parameters. Those are unsigned 32-bit. And then I have 6 analog to digital converters that I use for the potentiometers. So that's a buffer that stores that. And then I have some buffers I use, floating point buffers that I use for the circular buffers that are 20,000, 32-bit floating point, each one for the left and one for the right. And I use those for the circular buffers. I could get a maximum of a 1 second delay for the left and right channel. The RAM is sort of limited in these microcontrollers, so I can't do too much over that in terms of delay. And I have some indicators here that I use for time frame overruns to help troubleshoot things. And this is what I call the instrumentation buffer. So I set up these arrays that I could store data and dump it out later. I call them instrumentation buffers. So I have some floating point. I have a fixed point here that I can use to record data and play it back later. So I could look at it to do certain tests. So I have a thing called the user switch, and that's what actually triggers this off. So if I push, there's a blue switch on the Nucleo board. If I push that, it'll store the data for a short period of time, so I could go back and dump it out and look at it. So here's a lot of just universal parameters. I have 1 is equal to 1 and 2 is equal to 2. Just I have a lot of temporary. These are all floating point. Pi 2 is a common parameter. I have -1, 16. These are just different parameters that could be used over and over again. So this is my effect selector. So this determines what effect is used, and it gets incremented by those switches, those the ups and down switches. So I have some debounce on those, on these up and down switches. I have to hold it in for so long for it to increment the effect. So that prevents bounce issues. And this is some flags I use to tell the system when to write into the LCD. It's an I2C LCD. And then I have general purpose switches. Those are the 4 extra switches that I can use to change the effects. And I have some parameters to scale the pots. So the pots eventually become a floating point value that could vary from -1 to +1. And I have some filters for the pots to try to get noise out, so it's a nice smooth signal. So this is the area where I start all the parameters for the different effects. So I was following a rule. You don't have to do it this way, but this is the way I've been doing it. I put like an E000 for effect 0 and E001 for parameters. I have to do effect 1. And these are parameters I have to do with effect 2, and so forth. So you go all the way down. So we're going to go down. I think I had 43 effects. So these are all the parameters I have to do with each effect. So I'm going down, and we have, so far I believe we have 43 effects. So so these are the parameters, and it's kind of endless. So I have enough here for like 10,000 effects. But you can always load different software in to get even more. So this is auto-generated. So these are some of the prototypes for the drivers, and these are prototypes for some of the subroutines that you have to hand code in. I had to hand code this in. So this is the top of the main function, and when I start up with the debugger on, it always starts out here, this HAL init. So this is all auto-generated code, but this is the code I put in user code to begin. So this is computations that don't need to be in the main loop. They are only computed one time, so it's at the beginning of the program, but it's things that just have to be computed one time. So some of the effects need some parameters that are computed one time. So this is setting up the registers for the I2C interface for the audio codec. And so these are the initial instructions I need to give it in order to initialize that and get it in the right mode that I need to communicate with it. So that's always a big trial and error type of work to do to try to figure that out. But it's all kind of done here for you, so you could kind of take that if you want that. So so initialize the LCD display, and these are all I2C transmits and receives. And over here, there's a UART in there that I use for this instrumentation buffer. So if I connect it to TerraTerm and look at the RS-232, the first thing it says is welcome to sound H723. It should really be 13. This is program 13 on this, and this at the very beginning it'll dump out the data that I use for instrumentation. So over here, let's see, this is the transmit for the UART, and this is a very important one here. This is the I2S interface. So it's transmitting in the background. It's getting data. It's 64 bits of data transmitted and 64 bits of data received for the 2 stereo channels. So this is using DMA, direct memory access, to transmit and receive that data in the background. So it doesn't hold up the processor. So this is run one time, but it runs in the background. And likewise, this is for the analog to digital conversion for the 6 pots. So this is uses DMA and runs in the background. And this is the interrupt, this is the main timer 3 that sets the interrupt for the 20,000 hertz, and we'll get into that a little bit more. And this is the start timer for the ADCs. This is only reading the ADCs at 50 hertz. So these are like output compare timer. So I'm doing a little bit of a walkthrough for this code. So this is where the main while loop runs in the background. So I have some things here. I hadn't really tested this out thoroughly yet, but I was trying to see if I could detect a time frame overrun, and if it does, it turns a red LED on. So it turns on the red LED if a time frame overrun is detected. Now, time frame overrun is if it takes longer than I have more instructions that I could fit into that 20,000 hertz frame. It'll light the red light and give me an indication, yes, something went wrong and I overrun. This is the command that turns that on. If I detect, if a time frame overrun is detected, it'll turn that on. So this is the main interrupt flag. So when this while loop is constantly being exercised, but if that's equal to 1, then it runs this code, and this is the code for my effects. So the first thing I do is I have a green LED I turn on and off at the 20,000 hertz. This gives me, I can look at this on an oscilloscope to know, yeah, am I overrunning the frame, or do I have enough instructions? So that's an important thing to have. And this is more things to try to detect if I have a time frame overrun. And this is the ADC processing that I need to do for the audio codec. So it comes in like fixed point, that's the raw data, and I converted it here to assigned integer here because they're coming in as unsigned integers, 32-bit integers. Then I use it's called casing. Set the do casting. It's called casting. So I convert the signed integer to floating point. So that's how you do it using the casting. It's called. So I do a thing where I normalize it. So the normalized signal is never greater than it's within the bounds of plus or minus 1. It's a floating point number. So if I search for this norm gain, let's see where if I can find that. So I'm going to do a search where I set norm gain. This I'll show you where that's set. Okay, this is a different one. That's for the pots, but the norm gain set over here. It's a very big number. So this is the 32-bit, range. So if you take 2 to the, I believe 31, you'll get that. So that's how I normalize it. There's that code again. So I'm just doing the walkthrough of that code. So over here, I process that up switch and the down switch, the 1's up and the 10's up. So I could increment my effect. So this is the logic that'll increment that effect. And so I can only go up to 43 effects. If I add more effects, I have to increase this number here. And this is to read these switches. I have switch 1, switch 2, switch 3, switch 4. Those are just discretes. So anyway, this is where I put my codes. So I'm using a switch case break, switch case break. So if effect selector is equal to 0, it runs this code and then skips out. If it's equal to 1, it runs this code. So this is the code to do a 440 hertz A note sine wave, which is one of the tests when the box first starts up. That's what I do to know that the box is working. So these are all my effects. These are second order bandpass filters. So it goes, it continues all the way down, and we're going to go through some of these effects more, some of the code. So I'm just quickly going to go through this till I get to my last effect, which is 43 here. Right. So usually at the very end, I have an output that I set to the DAC. So that goes back to the audio codec. So let's see, what do I have over here? So here I have some processing. Unnormalize the signals. I want to send it back out. I want to take the normalized signal, which has a range of plus or minus 1, and make it an unsigned integer again that I could send back out to the audio codec. So what I do, there's a limit. So I don't want to go over that limit. And then in that norm gain, you can see that back again. Since this is plus or minus 1, I convert it back to a signed integer, and then convert them back to unsigned integers. Right, and for effect 32 is just a feed through. So that's how I do it. I just set the one buffer to the other buffer, the receive buffer, the transmit buffer. So that's like a special case. So this is where I increment my frame counter, and which updates 20,000 times a second. And this is where I get my time. It's just the sample time. The sample time times the frame counter will give me time. So now here's where I start processing the pots. I get the raw data. In a similar way, it's a 16-bit unsigned integer because it's a 16-bit A to D converter. Then I convert it to floating point. And then I want to normalize the pot for a signal, a floating point signal between -1 and 1. And then I try to quantize it. I made a little routine because if I don't, on delays, to get any noise in the pot will upset the delay. So I just made a quantized version of the pot. And this is my user switch to fill those instrumentation buffers. So that's how that's done. And this is at the very end, the interrupt flag. And at the very end, where I turned on that discrete, I turned it off. So that's the green LED. So over here, anytime leftover time in the background is use the right messages to the LCD. So these are for effect 18, it writes this message out to the LCD, so I know what effect I have. And I can also see it on the debugger when it's running, but normally the box isn't hooked to this computer. It runs standalone without the computer. So that's pretty much the end of the code there. This is things to command that LCD. And the only thing I had left are some of these functions in the end. So we'll go, all this other stuff is auto-generated. You don't have to worry about that. But yeah, this is user code section 4. So I have a lag filter. This is the algorithm to do a first order lag. And this is the algorithm to read to write I2C data. I believe that's to the, right. This is writing to the audio codec, and this is reading from the audio codec. This is like the control part, not the I2S, but this is the I2C part. And then this LCD is an I2C LCD. So that's how I send data to that LCD for displays. And this is the setup for the LCD. So there's a send command and send data and initialize the LCD. And this is sending a string. So that's pretty much it. That's all the code. So I wanted to walk through that with you briefly so you get an idea of what it takes to do this.